All right, last class I asked you, I gave you this integral formula, and I said, why must a be greater than 0? And I asked you to think about it. Well, if you think back to log base 10, 100 equals 2, 10 squared equals 100. If I say that log base 10 equals a negative 100, what's this going to equal? In other words, if I change it to this format where I have the base and the exponent, what would the exponent be to give me a negative 100? Can't be done. So the a here is represents the 100. Right? So it's impossible to do it. Therefore, a must be greater than 0. Frequently, they'll put the a in absolute value signs. One of your classmates wrote to me and asked me why I made this log, natural log 0.2. So let's just go over this. Integrated, I'm going to end up with 1/5 to parentheses theta, natural log 1/5, and your limit, your upper limit, lower limit, 0, -2. I changed this to 0.2 because frequently in math problems, 1/5 is equal to 0.2, or 2/10. Sometimes a math problem is easier to solve it with a decimal fraction than a ratio fraction. As I was doing it, and I thought I would just jog your memory and put it both ways. So I brought it back and changed it back to natural log of 1/5 because it's easier to deal with. You'll get the same answer if you use a natural log of 0.2. And you can try it if you want. So we end up with this, substituting in 1/5 to the 0 power is going to give you a 1. And this is going to give you natural log of 1 minus natural log of 5 minus 1 to the -2, 5 to the -2 over natural log of 1/5. So this gives you 1 over 0 minus natural log of 5. Give you 1 to the -1 over 25 to the -1, natural log of 1 minus natural log of 5. You invert these, so you have a positive exponent with the 25. Natural log of 1 is going to be 0. So you're going to have 1, I'm sorry, -1 over natural log of 5 minus 25 over natural log of 5. This minus here comes from here. All right, so you're going to have -1 over natural log of 5 plus 25 over natural log of 5, which will give you 24 over natural log of 5. All right, try problem 68. Y is equal to 3 tangent theta, natural log of 3. The derivative of tangent log of theta is going to be secant squared u derivative du. So pause the video, try it, and then check it. All right, so y is equal to 3 tangent theta, natural log of 3. Take the derivative of it. It's going to be 3 tangent theta, natural log of 3. And then I take the derivative, which is going to be natural log of 3 secant squared theta. So you'll end up with natural log of 3 squared, 3 tangent theta, secant squared theta. So the solution to this comes from the derivative formula on page 84. A to the u, so you can write a to the u. All of this is a to the u. So I rewrote it, and then it's going to be natural log of a, well 3 is the a, so natural log of 3, and then the derivative of u, which is going to be secant squared theta. Alright, so natural log of 3 times natural log of 3 gives you natural log of 3 squared. All right, let's take a look at number 91. Okay, first thing you want to do with 91 is you want to substitute u equals x squared. So go ahead and substitute. Pause the video, try substituting, see what you get. Alright, so I substitute in, I get du equals 2x dx. Well, I have a dx, I have an x, but I don't have a 2 here. I have 2x x squared. So I have to divide this side by 2, which gives me 1/2. I get x to the dx. I'm going to get 1/2, 2 to the u du. So I can substitute this in for the dx and the x. Now I have to worry about the limits. So since u is equal to x squared, I substitute 1 in for x. I get 1 squared, which is 1. Then I substitute square root of 2 in for x. Squared gives me 2. So my new limits are, the lower one is 1, the upper one is 2. Now I integrate it, I'm going to get 2 to the u natural over natural log of 2. That's 1/2, 2 squared, natural log of 2, minus 2 to the 1 over natural log of 2. It's 1/2, 4 over natural log of 2 minus 2 over natural log of 2 equals 1/2 times 2 over natural log of 2 gives me 1 natural log of 2. I try integrating that number 112, pause the video, see how you do with it. So the integral of this is going to be natural log of t. Substitute in e to the x for t, and minus natural log of 1. Natural log of 1 is going to be 0. So I have the natural log of e to the x. Under the properties of logarithms, because this base is e, the answer is going to be x. So take a look at number 114. Alright, so 1 over natural log of a, the integral of 1 to x, 1 over t dt. This is going to give you the natural log of t, and you're going to integrate it from 1 to x. You could actually do this to it if you wanted to. So it's 1 over natural log of a times natural log of x. You substitute minus natural log of 1. You multiply through, you're going to get natural log of x over natural log of a minus natural log of 1 over natural log of a. Natural log of 1 is 0. So end up with, this should have an x here, natural log of x over natural log of a, which is equal to log base 10x, with x being greater than 0. If you see page 85, you'll see this formula down here. Number 18. 118. All right, try 118. Y equals t to the 1/2. You want to take the natural log of both sides. Okay, I may have paused this video and by mistake and didn't pause it when I was supposed to, so you may have a blank space on the video. Don't worry about it. All right, for 118, y is equal to t times t to the 1/2. The best way of doing it is natural log of both sides. When you do that, this exponent of t to the 1/2 becomes a coefficient. Now you can take the derivative of this, which is 1 over y, derivative of y equals 1/2 t to the negative 1/2 natural log of t, taking the product rule, plus t to the 1/2 and the natural log of the derivative of natural log of t is 1 over t. All right, so you end up having natural log of t over 2t to the 1/2 plus 1 over t to the 1/2, because you subtract your exponents there. So you end up finding a common denominator, which is this. You're going to have natural log of t plus 2 times t to the 1/2. Solving it for the derivative of y is going to give you y times this here, substituting t to t to the 1/2, and you end up with an answer. This becomes your answer. All right, try problem number 120, y equals x sine x. Pause the video and see how you do it. All right, so what you want to do is take natural log of both sides, natural log of y, natural log of x sine x. That exponent becomes a coefficient. Now you take the derivative of natural log of y, which is 1 over y, and the derivative of y. And derivative of sine x is cosine x. Rewrite the natural log of x, plus bring over the sine of x, the derivative of the natural log of x is 1 over x. Bring the 1 over y to the side. So you're going to multiply y times cosine of x, natural log of x, plus sine of x over x. That's all in parentheses. Substitute in x, the sine of x, and that's your answer. All right, let me put your homework on the board. Homework, page 86, numbers 67, 68, numbers 111 through 115, and numbers 117 through 120. Have a great day. I will be sending you out an email, probably with handout on it and some other information.